going on with the smart meter? First and foremost, it's a billing mechanism. That's the whole point of a smart meter, is to take your measurements. Take it in a lot of different ways, take a lot of small little bites of it, take it, there's several different dimensions of your electrical use that it's going to measure beyond what your analog meter measures, but it's a billing mechanism. It is not necessary to upgrade the grid. People will talk about the utilities, we'll talk about smart meters, well, you got to have them, we have to upgrade the grid, our grid is falling apart. That's not part of the grid per se, that's a billing mechanism. It's non-essential. You don't need smart meters, period. We could upgrade the grid and keep our analog meters. There are other ways to do the things they want to do with smart meters that don't require a smart meter on every house. So it's a digital meter that's gathering much more data, like I said, different parameters like the startup power, the draw power, as well as the steady state run power. There's like 4 different parameters that they measure. So it's going to gather a lot more data. It's going to take it in snapshots of 5 to 15 minutes, depending on how the meter is designed or set up. And initially they're saying, DTE is saying, well, it's only 4 to 6 times a day. We're just going to send this out 4 to 6 times a day. Big pile of snapshots of 5-minute or 15-minute increment snapshots. Well, that's your own meter sending its own data 4 to 6 times a day. And even that could change. This is a software parameter. It's just a field. How many times a day do you want it to collect? Well, now it says 6. Well, tomorrow they could put in 24. They could put it in every hour. They could put in every 15 minutes. It's just a field. It's just a software parameter. So that could change at any time. It just sounds better for them to roll them out and say, well, it's only 4 to 6 times a day. Well, today maybe. Tomorrow probably not. So in addition to that measurement data, the meters send all kinds of other messages. There's network messages that are going out. Those are going out every few seconds. This might be 4 to 6 times a day on your meter. All the rest of these messages are every few seconds. So when you add together all the messages, the data measurement and the network messages, and you put them all together, they're going to hop from meter to meter to get back to a designated collector. Think of it like passing notes in class. You're going to have somebody at the back of the class passing notes to the front, and it's got to get passed through all the students in between until it gets to the front of the class. That's the way the smart meters are operating in a mesh network. And when it's sending out this radiation, this isn't a beam. This isn't like a flashlight beaming to the next meter. This is taken from the Electric Power Research Institute report, a 222-page report, came out December of 2010, on smart meters, specifically looking at the Itron smart meter, which is what DTE is using. And the pattern that you get, this is taking this in the soundproof room that I talked about, the pattern that you get is a globe, pretty much. You've got the metal box of the smart meter, and yeah, that's going to block a little bit of the rays, so there, you have a divot in the pattern of the rays. And you see it again here, you see this is a weaker power density than up here, it's darker and more intense. But the point is, you get it behind as well as in front. You get it in all directions, up, down, sideways, it's a globe. It's going out omnidirectional, going out in all directions.
So there's no antenna gain at all?
There are different antennas they can use.
But I'm talking about, but not from a directional perspective. I mean, it could be amplifying antennas, but not...
Well, they do have directional antennas depending on what all is in their system and how they're using it. The basic smart meter is omnidirectional, just going out in all directions. Okay. So now we're going to look at a neighborhood, and how does this really work when you're talking a mesh network? So here you've got your collector up here. Here's a little neighborhood of houses. Let's say the collector wants to get this house's data. Well, that house could get up here. It can come across and up. It can go up and across. It can go diagonally. It could zigzag its way up and come across. That's going to depend on what path has the best signal minute by minute all day long. The meters are talking to each other all day long to say, can you hear me now? Good. Can you hear me now? Good. And the collector is listening to this chatter of the meter saying, this one is strong, that one is weak, this one is just okay, this is the best, I like this one. Right now I like this one. So when it's ready to collect information, it picks the strongest path. But that's going to change by time of year. If you've got leaves on the trees, they're going to suck up that RF, and so you want a path where there aren't any trees. You might have a snowstorm going on, you've got different things happening. You might have a moving van come in to move your neighbor, and all of a sudden there's a big metal wall between your meter and the one across the street. The path is going to change minute by minute. You never know what path your house's data is going to take to get back to the collector, or how many meters are going to pass through your house in order to get to the collector, because it's always changing. Now the next goofy thing is, they're not set to go at certain times. The collector has to ask for it. So the collector will ask this house to ask this house to ask this house, send me your measurement now. And it sends it back to this house, who sends it here, who sends it to the collector. Let's look at what's happened here. You've had one house's data sent. This one is transmitted once, this one twice, out and then out this way. This one twice, this way and that way. And then back to this way is another one. So you've gotten two here, and one there, plus the transmission from the collector. So you've had 6 transmissions to get 1 meter's data. 6 wireless transmissions. Next. And each one of these is putting out a big red ball of RF. So where you get the overlap, guess what we said about adding together arrays that intersect? You've got hotspots. Now somebody had asked me once, well, but they're not all going off at the same time. That is true. But you've got a spectrum of 902 to 928. And they can be taking, multiple meters can be sending on these different frequencies within that range at any given point in time. So you are going to have simultaneous meters going off. And if they're overlapping, if they're intersecting, guess what? You have hotspots. So that's what's going on just on this nice, neat, one line connection here. Next. Now what happens when you're trying to collect from the whole neighborhood? That was just showing you that one line of collection. Next. That's what you get. We call that electrosmog. When you have all of these meters and they're not 100% going off all at once, I grant you that, but you will have many of them going off at the same time. And you're going to be getting assaulted moment by moment from the different meters because your meter's going off so many times a day, the one next door is going off, let's say the same number of times a day, but slightly different. Maybe 5 seconds later, yours is going off, and so on and so on and so on, all the ones around. You're being assaulted by radiation in a mesh network. It is the most unhealthy way to get this information back to the utility. Yes?
How does the meter know where your house is and not the neighbor's house? It's like
the meter's connected to your house.
it's connected to the wires in the house.
To the electrical wires in your house. Yes, measuring the flow of
It's only
electricity.
measuring electricity from the house.
No, it's only measuring your house. It's only measuring your house. Although one of the interesting things they found with these meters in some places is when they get hot, they run faster. And they think you're using more electricity than you are.
When the meter gets hot.
When the meter gets hot. So that's another problem, is you might see your bill really skyrocket in the summertime, and it's not just your air conditioner that's causing it. Yes?
If they, in my neighborhood, they've installed them on everybody's house but mine and a couple other people.
Yes? That's a lot of
Once they've installed them, are they up and running, or do they install them but they're not doing all this stuff here?
Once they install them, the very first thing these meters do is say, where's the collector? I gotta register. I gotta figure out where my home base is. Where's the collector? And they start talking to each other and start trying to find what's the shortest path, what's the nearest collector. They call it registering. They're registering with the collector. So, yeah, once they've been traded out, if they're not sending, then how is the utility getting their measurements?
Okay, so once they're there,
Once they're there, they're running. Okay, they're up and running.
I called DTE to ask that question, they wouldn't answer it. I called AccuRead, they wouldn't answer it. They told me to call Itron that makes the meters. I spoke to a guy, I emailed the guy. I got an email back from him today that said, we really can't answer that question. It would be best if you contact your utility.
Of course. That's the bug.
It was just a simple as
It was a simple question, and you have your answer. Okay, yes.
I got out the day I received my letter that we're
Yes.
going to install,
Yes.
and they okayed me. I thought we were going on vacation and we came back and they installed me. What can I do to get that off my
You demand, now, when you told them you wanted it off, did you send a registered letter to them that you did not want the meter in the first place?
No, I called DT Energy and they talked to the supervisor. The supervisor contacted the people that would be installing it. It was okay. It's on my record at DT Energy. So when I got back, I called and I said, everything is blinking. What has happened? Well, the company that installed them didn't get the message in time. Why not? It's been 2 weeks, but they had it.
It's full. It just is.
So someone was supposed to contact me in 2 to 3 days. Today is day 2. I want that thing up tomorrow.
You call them every single day, and And then you start escalating your demands. You say you're thinking about getting a lawyer, that you have insisted not to have it, and they've violated your wishes. They do not have they basically invaded your privacy. They did not have your permission to put that on your house.
And so that's true for everybody? They got nobody's permission.
Well, they have implied permission because you are getting service from them, and they can put a meter, if they need a newer version meter, they can do that. That's what they'll say. Unless you expressly say, I do not want that meter, and put it in a provable format, that's where it says registered mail.
But what if it's already on your house?
Then you have to start demanding that they take it off.
Well, what are you saying? So what kind of letter can you send concerning that?
Well,
letter?
you start sending letters, but the problem with the letters, they just ignore it, you never hear anything back. It's like you won't hear back unless you talk to somebody. Then you send them a letter in writing about what the conversation, who you're trying to take on the person's name, if they have a badge ID number or whatever. You take down their information, the time, the day, whatever, and then you send a confirmation letter, registered mail to them. I talked to you on this day. You said that you were going to take care of it or get whatever it was that they said and committed to you. You send it back to them in writing, registered mail. And you do that for a while, and trust me, you're not going to get a lot of response initially. It'll probably come down to threatening to get a lawyer. I don't know if you'd be willing to go that step, either the threat or the follow-through with a lawyer.
But there some kind of class action lawsuit going on? I mean, why can't we do a class action lawsuit?
Well, there are a bunch of people that join you, and absolutely, I'm all for it. Yes.
And maybe that's why we're getting a class action. I mean, what?
Well, one of the things that I would suggest is that somebody get a petition going about who would be interested in a class action lawsuit to just halt this whole thing, and how many people want the meter off their house permanently.
Make sure when you send your letter that you want your analog.
The analog meter, because the digital meter that doesn't communicate wirelessly still makes people sick. The way it's designed, it creates dirty electricity, electrical transient.
Say that again. So you want
you want your analog meter, the old one, you want it with the little wheel spinning around, that's what you want. You want your analog meter.
And they won't do it.
If you're going to do a lawsuit, ask for what you really want, which is an analog meter. That's what you need.
Why don't we send something around in this room right now, because obviously all of us are engineers.
Sure. Does anybody have some paper that they could get that going? I don't have the sign in back there, but that's not specifically to say petition to.
So you can just write petition.
Okay, petition. Sign in sheet, yes.
Yeah, I have a question, about this dirty electricity. So, my experience, I'm really sensitive to this stuff. I've been in 2 houses with smart meters. I've been in 3 houses with smart meters, possibly 4. And actually 2 of them I didn't know it at the time. And when I was in these houses, and when I was in at 2 different times, and it felt different each time, I felt it was like there was stuff coming in, and then stuff coming in, and it was like it's like for me in Best Buy, it's the same thing. And then in addition to that stuff coming in, there's just like this some kind of weird vibration.
You're probably getting exactly what it is. It's something that a lot of people feel.
Yeah. But what are we getting the dirty electricity as well as the wireless radio?
That's what I'm wondering about. So more the vibration is more the dirty electricity, and this other weird stuff.
I don't know the answer to that question specifically. I'm just saying, you're feeling 2 different things. You're probably getting 2 different sources. And that the dirty electricity is because the smart meter has to take 120 volt alternating current, AC, that comes in, electric power, and then they have to break it down to somewhere between 3 and 10 volt direct current, DC, to run all the little micro components that run inside the smart meter that are adding up your 5 minutes usage at a time, storing it, whatever. So it's this translation function. They call it a switched mode power supply. The switched mode power supply, this breakdown function, creates dirty electricity.
And so that doesn't happen with an analog meter?
Correct.
And it's only happening because they have to run their smart meter?
Correct.
Oh my God.
Yep. Different.
Is there a way, without breaking any laws, to actually shield these things? So they become useless to this.
Wait a minute, useless?
Well, they can transmit the signal
Okay,
to the tower.
if you're gonna prevent them from transmitting the signal, then you are interfering with their stuff, and that's probably breaking laws. If you are trying to lock an analog meter down onto your house, even that is their meter, and so you can't prevent them from taking their meter. This is a gray area. The utilities in different states have responded differently to different approaches of how you block this. The only thing that's totally legal is to go inside your house and do all the mitigation you can to block it out from coming inside your house. There's certain paint you can get that'll do it. There are fabrics you can put over your windows for the curtains. There are different things you can do with mitigation experts to block all of this radiation outside, keep it outside your house.
What's the name of the paint?
I'm sorry?
What's the name of the paint?
I don't know, you have to Google that. I just know there is such a thing, a special paint that one.
What happens to wrap letter on?
Wrap letter on the vehicle, well, then it's not going to transmit, and then they're going to come out and say you're tampering with their equipment, and so you could end up with some kind of fine.
Stealing energy.
No, stealing energy? Well, yes, they can't bill you, they'll say you're stealing energy. Yes, yes.
But if you're saying this stuff is bouncing off
No, it doesn't matter.
all different directions,
Yes.
right?
Yes.
So technically probably going right through your house, right?
Correct.
The only way you could do it is to have the paint on all the walls.
Correct.
And the ceiling.
Correct.
And the blinds closed all the time.
And
you have to have,
yeah,
you have to have bomb shelters.
Yes, crazy, you couldn't go on a walk ever, That's why we have to stop this. It's crazy. Okay, let's go on to the next one. So that was just the meters house to house to house. So here's how your little neighbor goes with your meters. Then they have to get the collector's data back to the utility. And oftentimes there's a whole other mesh network of wireless broadband that's got their own radios that are sending it back to the utility. So there's yet another layer. So you've got the home area network going inside your house, the smart meters going house to house, and then some kind of a bigger network over the top of that that's sending it all back to the utility. Yes?
What frequency do they transmit that at, and is it the same as what we're talking about?
Okay. I can't speak to DTE because being that they're a utility, I can't make them tell me what they're using for this. In Naperville, Illinois, they are using Tropos brand wireless broadband, Tropos network wireless broadband routers. And they are dual frequency, 2.4 gigahertz and 5.8 gigahertz. And the reason is what I said earlier about spectrum, the 5.8 gigahertz penetrates, and I had an engineer tell me, it cuts through the clutter. And I said, what does that mean? He goes, oh, trees, houses. I said, people? He said, yeah. So the 5.8, the higher frequency, is really going to cut through everything. The 2.4 goes further than a 5.8. So you'd have to have all these routers closer together with the 5.8, but it'll penetrate anything in between. The 2. So it was a dual frequency to use whatever works best in a given scenario. But I don't know what DTE is using. That's what they're using in.
But that's a market technology, too.
Yes. Yes. Yes.
So is the data collection center, is it really on somebody's meter, or is it a separate place that someplace in the neighborhood?
It depends. Again, I don't know DTEs as intimately as I know in Naperville. In Naperville, there is a commercial grade meter. It's a little bit bigger. It's a little bit more robust, has more memory, and that was collecting the data. But so they could either collect it off of a commercial building with the meter, or they could mount it on a light post or something. There's different ways to go about it. But the reason I know Naperville so well is because the city owns their utilities, so you can use the Freedom of Information Act to demand documents. So I got all kinds of insights that you can't demand that DTE or consumers or somebody tell you. I got it because the city owns the utility. So that's why I understand how they work, and they all work basically the same. I just don't know what brand router they're using and what frequency it's using. Yes?
Within the last 6 months or a year, I've seen those white antennas go up all around
That sounds like wireless broadband. They're like a little box with sticks sticking up out of them.
little white spikes. But someone actually put one on my building without my permission. And I tried to call around to figure out who did it. And the city doesn't know, the county doesn't know. So I disconnected it. But anyways, I'm wondering if that's what's communicating to the main tower.
Again, I don't know all the different brands of wireless routers. I just know this is the basic configuration that the utilities are using in a mesh network.
Okay.
Yes. Okay, thanks. Now we get back down to how many times is it really going off in a day? Pacific Gas and Electric was challenged in court in California, and a judge asked very specific questions of what these meters do. They asked for what are the different kinds of messages, and that what they asked was schedules, because then there's unscheduled messages as well. These are just scheduled messages, regularly repeated messages. What are the different kinds of messages that get sent? How many times do they get sent on average? And how many times do they get sent maximum? So here's the interesting little 6 times a day meter read data. Well, your one meter will send its own data. This is PG&E 6 times a day. Sounds just like here with BTE. Then you have network management. It's got to stay synced up. So now you've got 15 to 30 network management messages in a 24-hour period. Then you've got to make sure they're all talking to each other at the right time, because you don't want them bashing into each other. So they all have to be running on the same time schedule. 360 messages per day for time synchronization. Here's the biggie, the relays. They're going house to house to house to house in order to get back to the collector. That's what they call mesh network message management. On average, these are added together, there's the total. On average, 9,600 mesh network message management on average in a 24-hour period. The maximum, 190,000 messages in a 24-hour period. Then you add all these together, this is about 10,000. 9,981 on average. 10,000 messages a day on average. What's going to make the difference between being in this column and this column? Number one, how big your network is. Per collector, how many meters is it gathering together? So that's number one. Number two, how close are you to the collector? If you're the first house off of the collector, guess what? All these hundreds of meters are passing through your house in order to get to the collector. That's how you end up in this column. So when you're looking at that many transmissions a day, so if you're looking the average transmission, the 9,981 messages every 9 seconds, every 8.66 seconds. That's if they were evenly distributed, which they're not. They're going to cluster. You will have clusters, and so when you have a measuring device, you hear, you hear this chatter where you have who knows how many, 10 or 15 messages going off in a span of 10 or 15 seconds. But every 9 seconds on average. And that works out on this duty cycle business. You average it out by the total seconds in a day, 0.0005. That's the duty cycle. And they go, what's the big deal? It's only a duty cycle of 0.0005. And yet, that's every 9 seconds. Now let's go to the maximum. When you get the maximum, the 190,396, every half a second. If you space them out evenly, 2 transmissions per second, 24 hours a day, 365 days a year. And even that, twice per second, is a 0.01 duty cycle when you do the math. And the reason is each of these messages are so very tiny, they're like 20 milliseconds. So 21 thousandths of a second is what they are. And that's why, even having so many of them, they're 20 to 50, depending on what kind of message it is. That's why it ends up being such a short time. So they'll look at this one up here, and they'll say, well, what's the big deal? It's only 45 seconds. On average, your meter is only going off 45 seconds a day. How could that be harmful? Well, when it's every 9 seconds, that's a problem. Now, this again is very official. This is out of Electric Power Research Institute report at 222 pages from December of 2010.